So, welcome to electric forces. Today our discussion is on electric forces. So, when we talk about electric forces, which is also known as the coulomb force, it is the force that exists between two stationary charges, and these charges exert on each other this force. So, the force that two stationary charges exert on each other is called the electric force or the coulomb force. And this force depends on the magnitude of the charge and the separating distance between the charges. So the higher the charges, the higher the force, and the shorter the distance between the charges, the higher the force as well. So the proportionality between the forces and the charges is the magnitude of the charge and the distance between the two charges. So we say that the force between the charges is directly proportional to the amount of charge and same inversely proportional to the square of the distance between the charges. So as I said earlier on, the higher the charges, the higher the force, and the shorter the distance between the charges, the higher your force, and vice versa. So meaning greater charges and shorter distance between them will give you a greater force. So now mathematically we can express this as force being proportional to Q1, Q2, taking two charges, Q1 being charge 1, Q2 being charge 2, then R squared being the square of the distance between the charges. So F is proportional to the product of the charges and inversely proportional to the distance between the charges. So now bringing out the proportionality constant, we have K, which is the Coulomb's constant. So F equals K Q1 Q2 over R squared, which we can get an expression for our definition. Now taking this diagram, when we have two charges of the same charge, which is positive or either negative, they repel each other. So repulsion occurs between the two charges when they are brought together. So we see the blue arrow showing the direction at which the two charges will move when they are brought together, meaning there will be repulsion. And this diagram is when the charges are different. We have positive and negative. When they're brought together, there will be attraction. So the charges will be moving towards each other. That's why we have the arrow showing the force at which the charges will be moving. So the forces that these two charges exert on each other is an attractive force. And for the first diagram, it is a repulsive force. So you should understand that one too. If the charges are the same, it is repulsive force that exists between them. And if the charges are different, it is an attractive force. So the electrical forces obey the Newton's third law. That is, the forces are equal but act in opposite direction. So this implies minus F12 is equal to F21. So the minus sign is showing us that F12, which is force, the force exert or the force between charge 1 and 2 is opposite but equal to the force between charge 2 and 1. So this relation should tell us that the forces are always equal but they act in opposite direction. Okay, now let's solve some examples given the concept and equations and relations to electric forces. So the question says, calculate the force between two charged spheres of charges 1.5 times 10 to the power minus 7 coulomb and 2.9 times 10 to the power minus 7 coulomb, which are placed 30 centimeters apart. So we have two charges and the distance between these charges. So with our solution, we have our equation which says F equals K Q1 Q2 over R squared. And we should note the K constant, which is giving us 8.99 times 10 to the power 9. So you can round it up to 9 times 10 to the power 9. But it is advisable to use the 8.9 which is the constant value for K. So now, stating out the parameters given in the question, we have Q1, we have Q2, we have R, then we have our constant K. So what we will be doing here is direct substitution, since we have our values stated out from the question. Now we have to convert the distance into the standard unit, which is meters, because in the question it was given us centimeters. So we change R to meters, which will give us 0.3 meters. Now into our substitution, we have F to be equal to our K, which is 8.9 times 10 to the power 9, which was substituted. Then we have our charge 1 multiplying charge 2 all over the distance squared. So we change the distance to meters, which is here. Then we got 0.30. Now we simplify the fraction to get this value to make your work easy. After that, you multiply the fraction that you computed to the K constant. So the force that these charges will be exerting on each other is 0.004 newtons. So the unit for force is newtons. So the force between these two charges is 0.004 newtons. Now let's look at this question. Charges A equals 3 times 10 to the power minus 3 coulomb, and B equals 6 times 10 to the power minus 3 coulomb are placed at a distance of 2 meters apart, with each charge experiencing an electrostatic force on each other. Find the ratio of the forces between each charge. So this question wants us to prove either the forces between the charges are equal or not. As I said earlier on, that they obey the Newton's third law. This question wants us to prove if it is correct or not. But note that the question didn't give us the unit for the charges, either they are positive or negative. So we ignore them, then we just solve it as it is. So into the solution, we state our formula F equals K, Q1, Q2 over R squared. We bring out the parameters given in the question. We have our QA, we have our QB, we have our R, which is 2 meters, then the K constant. So now the first thing that you do is, since you want to know the forces between the charges, you write out two forces, which is FAB. So FAB means the force that charge A is exerting on B. FAB means the force that charge A is exerting on B. So it is given as K QA QB over R squared. Then FBA is the force that charge B is exerting on A. The force that charge B is exerting on A. So that is given as K QB QA over R squared. So we do a substitution for FAB, the K constant, QA QB, then the distance, which is 2. We square it to get our FAB, which was 4.1 times 10 to the power minus 4. So follow the steps, compute to see if you get the same value as shown here. Then now we do same for FBA. We substitute 8.99 times 10 to the power 9 into the equation, QB, QA, then the distance given. We compute it. Then we had 4.1 times 10 to the power minus 4. So from Newton's law, we know that the forces are the same. So the ratio of FAB to the ratio of FBA is 1:1. So we know that the forces are the same. So if we divide FAB over FBA, we will get 1. Since they are the same charges that we are computing for, the forces exerting between them. So this is actually the concept and the explanation that you need, the understanding you need from electric forces. The force that is exerted between two charges, or that exists between two charges, is proportional to the product of the charges and inversely proportional to the square of the distance between the charges. So your higher your distance separation between the charges, you lower your force. And your higher the magnitude of the charge, the higher the force. So we note that. Now the next thing we talk about in electric forces is the superposition principle. So the superposition principle takes into consideration more than two charges. So more than two charges exerting forces on each other uses the superposition principle. So this principle deals with resolution of forces. So let's say we have 4 charges and the other 3 charges are exerting their forces on the one charge or the individual charge. So with that, we use the superposition principle or the resolution of forces to find out the net charge that all the charges or other charges are exerting on the individual charge. So that's the concept behind the superposition principle. Now the superposition principle is mostly the resolution, which is summing up the forces that the other charges are exerting on the individual charge. So it's either you sum up or you find the resolution, which is using the F equals square root of F1 squared plus F2 squared plus F3 squared on and on. So you can use that to find the resolution of forces as well. Now there are 2 ways at which the superposition principle is applied. The first one is when the charges are aligned to position linearly. So the charges could be positioned linearly. With that one, there's superposition principle is applied there, and there's a way of which you go by it. And the second one is when the charges are aligned or positioned angularly. So when the charges are angled to each other, there's a way that we go about it. So let's look at first the linear superposition, how the linear superposition looks like. So looking at this diagram, we have Q1, Q2, Q3. They are all on the same line, so they are positioned linearly. Then with the charges given, Q1 is minus, Q2 is plus, Q3 is plus. So with the superposition principle, we carefully take into consideration the direction at which the force being exerted on the charge is moving. We take into consideration the direction at which the force that the charge is exerting on the other charge is moving. So this diagram is telling us that Q1 and Q2 are exerting their forces on Q3. So charge 1 and charge 2 is exerting the force on charge 3. So we are asked to find the net force on charge 3. So firstly, what we have to note is Q1 is negative and Q3 is positive. Now our Q3 is the reference charge. So when we talk about reference charge, it's the charge at which the other charges are exerting their forces on. So reference charge is the charge at which other charges are exerting their force on. So looking at the diagram, Q1 is negative, Q3 is positive. So there will be an attractive force, meaning Q1 will pull Q3 towards itself, which means Q3 will be moving to the left. That's why we have the arrow of F13 moving to the left. Now, F13 moving to the left side of Q3 means F13 is on the negative side of Q3. So that force will be a negative force. Then Q2 is a positive charge and Q3 is also a positive charge. It will exert its force on Q3, but there will be a positive force, meaning Q3 will move away from Q2, which will be on the right side of Q3. So the force will be a positive force since it is on the positive x-axis of Q3. So you should get the concept and understanding of this part too. The direction at which the force is moving determines the sign or the charge of the force. So if the force is moving on the positive side, it becomes positive. If the force is moving on the negative side, it becomes negative. Note that. And with your calculation, we don't include the sign of the charge. the sign of the charge. If the charge is positive, we exempt it. If it is negative, we exempt it. Note that as well. So given our charges here to solve this diagram, Q1 is minus 4.2 microcoulomb, Q2 is plus 2.6 microcoulomb, then Q3 is plus 3.2 microcoulomb. Now our distances are given: R1 0.70 meters, R2 0.45 meters. So we note that. So we are to find the net force on Q3. We have to find the net force on Q3. So let's look at the solution to this problem. So firstly, what we will do is, yes, we state our formula, which is already given. F equals K Q1 Q2 over R squared. So we should note the equation very well. Q1 equals F equals Q1 Q2 times K all over R squared. Now we state out the parameters given in the question. So K1 is given, micro is times 10 to the power minus 6. Micro is times 10 to the power minus 6. So we have our Q1, we have our Q2, we have our Q3. Then the distances between them, write them. Then we have K, 8.99 times 10 to the power 9. So now we listed out our parameters in the question. Now we have to find F13, the force that charge 1 is exerting on charge 3. So that equation will give us F13 equals K Q1 Q3 over R squared. So that's the force that charge 1 is exerting on charge 3. Then we have F23, which is the force at which charge 2 is exerting on charge 3. So that force equals K Q2 Q3 over R squared. You write that as well. Now we take the equations one by one, then we do our substitutions. So we have our K, which is 8.9 times 10 to the power 9. We have our Q1, then we have our Q2. Then now to the diagram. From Q1 to Q3, you're supposed to add R1 and R2 to get our total distance. We're supposed to add R1 and R2 to get our total distance. So we note that. So back to the solution. We added 0.7 to 0.45. Since R1 is that and R2 is that, we add those up to get our total distance. Then we square it. So after computing for F13, the value you have is 0.0914 newtons. So this is the force for F13, minus 0.0914 newtons. That is the force for F13. Now on to F23, we substitute the K value, which is 8.99 times 10 to the power 9. Then Q2, 2.6 to the power minus 6. Then Q3, 3.2 to the power minus 6. The distance between Q2 and Q3 is 0.45. So we add that as well to get the computed value. So after computing, we have 0.369 newtons. Now, since we did not resolve any of the charges or any of the forces, our net force will be F13 plus F23. So it will be a direct summation of the two forces. So our net charge will therefore give us 0.277 newtons. So you note the steps at which we had the two forces from both charge, then how we computed for the net force. Now to our next part, which is angular superposition. So the angular superposition deals with angles when the charges are placed at certain angles to each other. How we go about those concepts too. So looking at this diagram, we have Q1, Q2, these charges are placed linearly. Then Q3 is placed at an angle to Q1. We have R1, which is the distance separating Q1 and Q2. We have R2, the distance separating Q3 and Q2. Then we have R, the distance from Q1 to Q3. Then this angle is the angle at which Q3 is placed, which is theta. So this is the angle at which we'll be using to solve our equation. Now, F13 is the force that charge 1 exerts on charge 3. We are using the previous question to solve the angular superposition as well. So we are looking for the net force on charge 3. So F13 is the force that charge 1 exerts on charge 3. So it is a repulsive force because the charges are the same. So therefore, the force will move away from Q1, which will be coming at this angle. Then Q2 and Q3 will have a repulsive force. Therefore, Q3 will move away from Q2, which will be coming down as located here. So now we have our parameters given, Q1, Q2, Q3. Then the distance are given, R1 0.54, R2 0.39. Then the angle 47 degrees. So now let's look at how we go about this question as well. So take key notes about how we will solve the questions step by step, then you get the understanding. So our first part of the solution is you write out the equation. So the general equation for electric forces, you write it out, F equals K Q1 Q2 over R squared. Now you write out all the parameters given in the question. You have Q1, Q2, Q3. Then we have R1, R2. Then we have theta, which is 47 degrees. So K is our constant, which we already know, 8.99 times 10 to the power 9. So our parameters are written out. Now the first thing we have to do is we consider Cartesian plane when the superposition questions are given. Since they are placed angularly, we consider the Cartesian plane. So the first thing we will note out of this is we have to get f of x, then f of y. So f of x is the force from the x-axis, then f of y is the force from the y-axis. So f of x equals f13x plus f23x. So since we are having two charges which are exerting forces on F3, we consider those charges on the x-axis. Then we consider their charges or their forces from the y-axis. So since these two charges are exerting their forces on F3, we consider their force from the x-axis and their force from the y-axis. So that's how come we have equation 1, then equation 2. Fy is F13y, which is the force that charge 1 exerts on charge 3 on the y-axis. Then F23 is the charge or the force that charge 2 exerts on charge 3 on the y-axis. So we sum those up to get the total force coming from the y-axis. Now, before we do that, we are supposed to find F13 and F23. We are supposed to find F13 and F23. So therefore, F13 equals KQ1 Q3 over R squared. Then our F23 equals KQ2 Q3 over R squared. So you note the equation 3 and 4 as well. Now for you to find the x and y component, which is the resolution of the force, F13x from this diagram. So we drew an imaginary x-axis and y-axis for this force, which is F13. Then we brought out this angle, which is same to the angle that we saw in the previous slide, which is the question that was given. So the imaginary x and y axis will give us or will help us to get our f13x and f13y. So f13x equals f13 cos theta. So it is cos because looking at the angle and the position of f13x, the angle is adjacent to the x-axis, so given cos. Then f13y, the angle is opposite to that axis, which will give us sine. But the force f13 is found between the positive x and the negative y axis, meaning the x component of the force will be positive and the y component of the force would be negative. That's why we have our f13y here as minus f13 sine theta. So we take note of that. The position of the force on the plane really counts when you are bringing out the equation. Now our f23x is equal to 0 because the force f23 is only found on the y-axis. We can find the f23 force only on the y-axis, meaning our x component for this force would be 0. So when we come to the y component of this force, f23y equals minus f23. So f23y equals minus f23. This is because the force is found on the negative y-axis of the charge. So when we draw out a Cartesian plane across this charge, our f23 is found below the charge, which is on the negative y-axis. That's why we're having this equation. Now we are supposed to find r, which wasn't given in the question. So we will get our r using the Pythagoras theorem, since the angle or the triangle we picked out from the diagram is right angle triangle. So we have our hypotenuse, our base, and our height. So the hypotenuse will be equal to square root of the height squared plus the base squared. So this is how we go about the r calculation. So our r is equal to r1 squared plus r2 squared. So we substitute the values that were given in the question for r1 and r2 to get our r, which is equal to 0.67 meters, so that we can use that r value for our calculations. So these steps are supposed to be done before you even go into the main calculation of the question. You're supposed to get all of these out. Now, for you to get the resultant force, is the total force that is acted on or exerted on the charge 3. F will be equal to square root of fx squared plus fy squared. So we square the x component of all the forces, then y component of all the forces. We sum them up, take their square root to get the resolution force or the resultant force that is acted on the charge 3. Now let's delve into our substitution. So the first part that we will do is we will find the charge F13 or the force F13, which is equal to k1 K3 over r squared. We will do that, and after that we substitute our values. K, which were given, we put them into the equation, we compute them, we get 0.12 newtons. And after that we go to F23, we take the equation, we put the values in there. K is equal to the charge 2, charge 3, then distance separating. We put them inside, we compute, then we get our value, which is 1.06 newtons. Now, after getting the main forces, we now come into the resolution. So F13x is equal to F13 cos theta. So you substitute F13 that we calculated here, which is equal to 0.12. Then the angle, which is 47, you compute our F13x is equal to 0.018 newtons. Then now our F13y, which we had to be minus F13 sine theta, we do our substitution for F13, which is 0.12, then the angle, which is 47, After computing, we are getting F13 to be equal to 0.088 newtons, which is our F13Y. Now we know our F23X is equal to 0. So we note that value for that. Now our F23Y is equal to minus F23. So the calculation we did earlier on for F23, we just add the negative sign of it to get the F23Y value. Now after that, we now come to add up the X component and the Y component. So the X component will be equal to F13X plus F23X. We substitute them, F13X, which is 0.081, then F23X, which is equal to 0. We do that substitution, then we get our X component for the force. And after that, the Y component of the force, we have F13Y plus F23Y. We substitute those values, minus 0.088 minus 1.06. Then we are getting minus 1.148 for Fy. So after that, we resolve the X and Y component of the force to get the resolution force. So with the resolution, F will be equal to square root of Fx squared plus Fy squared. So with the additions we did earlier on for the X component, we do our substitutions here, which is F equals square root of 0.081 squared plus minus 1.148 squared. So taking the square of a negative answer will give you a positive answer. So we should not fumble over that. So computing for this value, we're having F to be equal to 1.159. We're having F to be equal to 1.159. So this is the resolution force or the total force that charge 1 and charge 2 exerts on charge 3. So the forces that they act or they exert on this charge is equal to 1.15 newtons. So this is the solution at which we go by to get our resolution force. So with the summary, we know that electric force is the force that two charges exert on each other, and that force is proportional to the product of the charges and inversely proportional to the square of the distance between the charges. So there are two ways at which we find the force between these two charges. That is when the charges are placed linearly or when they are placed angularly. So here are two examples that you can go through personally. So pause the video and solve these questions yourself and get the final answer. The answers to this question will be posted in the comment section.